So now let's talk about the power systems. This consists mostly of the solar arrays and the batteries. So the solar arrays are the most noticeable part of the whole space station. They are the solar arrays. There's 8 of them. There's 8 pairs, and I'll outline one pair. So here's one pair. 1, 2, 3, 4, and then these are kind of sticking out of the page based on this perspective. 5, 6 down there, 7, 8. So again, these are the most noticeable parts of the space station. So the solar arrays actually rotate 360 degrees every orbit. Now to show this rotation, I'm going to draw a line which is going to be the axis of rotation. So this dotted line is the axis of rotation, and the joint where they rotate is actually right about here. So this whole structure, these 4 rays and all these are actually radiators, we'll go over that later. This all can rotate 360 degrees. Same on the other side. So here's the joint here. Here's the pivot point, and then we can rotate fully around. So every orbit, these arrays are tracking the sun. That's what they're doing. They're moving around completely 360 degrees every orbit. Now, that implies that there is a kind of sophisticated slip ring system that can pass power through this rotating joint. So power can actually pass through this rotating joint and then go and power all of the modules. Let me erase this. So there are actually other solar arrays on the ISS. You can see them down here. The Russians actually have, on the SM module, these solar arrays are still fully extended. And the FGB actually had arrays, but you can tell that they retracted them. And the reason they retracted them was to get clear of these radiators. But these still create some power, and these create some power as well. Okay, let's also talk about the batteries. So those are solar arrays. The batteries are actually, you can see some of them right here. They're enclosed in this tray. You can't see some of them right here, but basically each system of 2 panels has a set of batteries that are kind of nestled with them right here. Some back here and some back here. So those are the batteries. So earlier I had mentioned that the arrays move around this joint. So power is actually transmitted through this joint through a slip ring. Since electricity can still pass through moving objects that are in contact, we can get electricity through a moving 360 degree moving system. However, you can't get fluid through there. And that brings us to our next topic, which is the thermal system. So all the components on the ISS generate heat. Even the astronauts themselves generate heat in their bodies. And all this heat has to be rejected. Now, on Earth, we take this heat rejection for granted in a way. All of our heat is lost through convection, so the actual air around us takes heat away. But in the ISS, there's no air, so this heat would just build and build on the space station. It has to be radiated away, basically. The only way to get rid of the heat is to radiate it to deep space. So to do that, you need something called radiators, and radiators are a way to optically send heat out into deep space, is a way to think about it. But first, you got to actually gather the heat. And the ISS gathers heat via a system of tubes that are circulating ammonia. So let me illustrate where that joint was about which the outer rays move. Now again, we can send power through this joint, but we cannot send liquid. So if we're going to have a cooling system out here, the cooling system has to be self-contained. We cannot send cooling liquid back into the core of the ISS. For that reason, each of these array sets has its own radiator. That's what these fin-looking things are. There's 2 on this side, and over here, there's 2 here. Now what these are doing is, there's a circulation system of ammonia on the ISS, and the ammonia goes through these tiny channels throughout this giant radiator, and it optically radiates the heat that was captured by the ammonia out into space. And it has to be self-contained. So these are self-contained systems that are radiating heat out here. Now, you can see that these large radiators in the middle do the same thing, but they are radiating heat generated by everything in the middle. So all these modules, everything on the outside here, anything that's generating heat through all these modules has to be radiated through these radiators. So these radiators also move. They can actually pivot. I'll do this axis line. They can pivot sort of this way, but they cannot pivot 360 degrees because it's fluid. They can pivot 100 or so degrees, but they can move if they have to. And the reason they would move, and the reason they would move at all, is to track away from the sun. You don't want to point to the sun because you want to point to something cold. You want to radiate. So they kind of have anti-sun tracking through their orbit. Now, right now, we don't actually use anti-sun tracking because we don't have enough heat to justify that. So when we do need them, these things would be kind of oscillating through an orbit as well, tracking the anti-sun vector, if you will.